Okay, so what we have here is 2 points. We have point A at 0, 0 and point B at 8, 6. And the question is, how do we find the distance between these 2 points? Now, a minute ago, we found the distance between points horizontally and vertically, and we said you could just subtract the 2 numbers. But here, we don't just have 2 numbers. We have 1, 2, 3, 4 numbers. So you can't count squares diagonally either. Now, some would say maybe you should just subtract the y's and subtract the x's, but then we still have 2 distances to work with. So another strategy would be to use the Pythagorean theorem to find the distance between those 2 points. So Pythagorean theorem, a squared plus b squared equals c squared. So let's make our own right triangle. Now, if you made yours up here, that's fine too. Either one would work. But just make a right triangle where you connect the 2 dots and then just fill in the rest of the triangle with the horizontal and the vertical. It's kind of like finding slope-ish of the line. And so from here to here is 8 squares, if you count. And from here to here is 6 squares. Aha! Now I have a right triangle and I know 2 side lengths. All I'm looking for is the distance in between those 2 points, the hypotenuse length for my right triangle. So let's come over here in our side work. A squared plus b squared equals c squared. So we're going to say 6 squared plus 8 squared. Don't forget 8 has to go in the c spot. Oops, just kidding. X has to go in the c spot. Okay, so 6 times itself is 36. 8 times itself is 64 equals x squared. We're going to combine 36 and 64. That's 100 equals x squared. And then remember always to get rid of a square, the opposite of squaring something is to square root. And what you do to one side of the equation, you always have to do to the other. So the square root and the square cancel each other. So on the right-hand side, we just have x. And now, to take the square root of 100, you ask yourself, what number times itself equals 100? And I hope you were thinking 10. And so 10 is the distance from point A to point B. Okay, so let's see if on part B here, you can try this on your own. We'll call this a you try. So you can pause the video and then check back and see how you did. Okay, so I hope you drew your right triangle and you figured out the horizontal change. The horizontal length of the bottom of this triangle is 5. The vertical change, or the vertical length here, is 12. Now it's time to plug it back into the Pythagorean theorem to see if we can find the length, the distance between the 2 points. So I'm going to say 5 squared plus 12 squared. In the C spot has to go x. I know 5 times itself is 25. 12 times itself is 144. So when I combine 25 and 144, because they're like terms, I get 169. And then our last step is to take the square root of both sides. Square root of x squared, those square and the square root cancel out, and so we get just x. On the right-hand side, you're asking yourself, what number times itself is 169? And that is a perfect square. It is indeed 13. All right, so to find the distance between 2 points that are not horizontal or vertical, you can use the Pythagorean theorem. You really have 2 right answers here. Pythagorean theorem. Or you're going to have to add a second blank here, the distance formula. That's going to be our second strategy. So the distance formula is a formula where you just plug in the ordered pairs, x and y, the numbers you have for those. So notice you'll always have 2 ordered pairs. One you could label x1, y1. The other one you could label x2, y2, right? And then you're going to plug them into this formula, okay? Now, when would it be advantageous to use the Pythagorean theorem, and when would it be advantageous to use the distance formula? The Pythagorean theorem is good to use if you have a grid. or graph, and the distance formula is probably faster to use if you don't have a graph. So this would be without graph, and this strategy would be with graph. Okay, so here's the distance formula. I'm going to copy it down. The square root of x sub 2, subscript 2, minus x subscript 1, quantity squared, plus y subscript 2 minus y subscript, can't talk, 1, quantity squared. And then if you need to, you can label your points, x1, y1, x2, y2. So here we go. We're going to replace my x's and y's with numbers now. We're going to plug them into the formula. So my x2 was negative 4. So we'll replace x2 with negative 4 minus x1 is 5. In parentheses squared, we call that quantity squared, plus y2, it looks like is negative 1. So I'm going to plug in negative 1 for y2 minus y1, where are you, y1? You are 2, parentheses squared. Now, super important here, somebody's going to mess this up in their homework. Don't let it be you. You got to use the order of operation. Your PEMDAS, your please excuse my dear Aunt Sally. Okay, so let's start with parentheses. Do I have parentheses? Yes, I do. So that needs to be my first thing I do. So second line here, we're still square rooting, but I'm going to combine the things in parentheses. Negative 4 and negative 5 is negative 9. Negative 1 and negative 2 is negative 3. Okay, we did that. Do I have exponents? Yes, I do. So let's do that second. Negative 9 times itself, be careful, a negative times a negative is positive 81. Make sure, lots of times my friends will call that negative 81. But as the answer to a square, anything, it should always be positive. Same thing with negative 3. Negative 3 times negative 3 is what this square means, is positive 9. Be careful not to multiply those two numbers. Do I have any multiplication? No. Division? No. Addition and subtraction? Yes, I do. So let's go ahead and add those together. The square root of 90. So at this point, if you are in advanced geometry, you would know to break down 90 into, let's see, that's 3 times 3 times 10, well, times 2 times 5, if you will. So that's 3 squared times 2 times 5. Remember, squares and square roots cancel each other, so this would be 3 square root 10. And that would be your answer in advanced geometry. Okay, so I've now pulled up my calculator on the screen. If you are in regular geometry, I'm going to let you utilize your calculator for this because we have not yet learned how to take the square roots. Okay, so we have never gotten out our graphing calculators before as a class. So once you have yours out, the on button is in the bottom left-hand corner. That's how you turn it on for the very first time. And so you'll notice you have your plain old number keys. On the right-hand side, you have divide, multiply, subtract, and plus. So you can use this as just a plain old calculator any old time you want. But there are also some special features on this calculator. There's lots of words that we don't know what they mean yet, and then there's also above all the buttons in blue there is something, and in green there is something. So if you want to access the blue feature of your calculator, if instead of a 5 key I want this to be an L5 key, all I do is press the blue button first, and now if I press 5, it is no longer the 5 key, it is the L5 key. Okay, same thing for the green button. If I want to activate, if I want to type the letter O instead of 7, then I would press the green button and 7 because it has a little green O in the upper right hand corner. Alright, so for this next part, In regular geometry, you would take the square root of 90. So if you can find the square root button, it's over here on the left, right above the x squared. It is in blue, so we will press the blue button first, then we will press x squared, and a square root should pop up. We're going to press 90 and enter, and our answer is 9.486. So we're going to, on our notes, write that our answer is 9.48, would round up to 9.5. And that would be our final answer for regular geometry. So notice that you have these squiggles here. The squiggles denote approximately, and we know that this answer is approximately 9.5, not exactly 9.5 because we cut off this decimal. We did not give the entire decimal. We stopped at the number 5. We rounded it up. Okay? All right, so pause the video, and I will meet you back on the next video. You try this next problem, and we'll check it together on the next video.